Dip brazing, definition, design, process, benefits and materials, complete details. Dip brazing introduction. Brazing can be achieved utilizing various techniques, each useful for addressing specific design goals or materials qualities. Aluminum dip brazing is a well-known procedure. What is brazing? In brazing, a filler metal joins the end of two pieces of metal. The two pieces come near one another so the filler can them. Then, at that point, capillary action causes the filler to flow into the gap between the two pieces of metal. What is dip brazing? Dip brazing is a brazing process that permits simultaneous brazing or joining of at least two base metals and utilizes flux in the filler metal. The filler metal, after cooling to the solid state, forms a strong metallic bond all through the joint area. The parts to be brazed subsequent to being chemically cleaned are assembled with the filler metal pre-placed as near the joints as could be expected. The assembly is then preheated in an air furnace to 1,025 F to safeguard the uniform temperature of divergent masses in the assembly. How to design for dip brazing. A. Select correct alloy. Utilize only alloys suggested for dip brazing, as other alloys will generally break down at brazing temperatures. B. Avoid fixtures if possible. Design parts to be self-jigging at every possible opportunity. C. Use lap joints for best results. Design brazed assemblies for lap joints for best outcomes. D. Allow suitable joint clearance. Joint clearance is represented by the way that capillary action causes the filler metal to be brought into the joint area. E. Provide proper placement for filler metal. Pre-positioning of the filler metal quickly adjacent to the joint must be provided for in the joint design. F. Consider filling and draining of interiors. Remember that a way should be provided for the flux to flow into and drain out of the brazed assembly. What is dip brazing process? 1. Assembly preparation. It is important to eliminate grease, oxides, and scale to ensure that the alloy wets the outer layer of the component's parts. 2. Application of flux. Apply flux by spraying, plunging, or brushing the components previously, during, or after the assembly. 3. Brazing filler metal. Different brazing metals as wire, washers, shims, sheets, and past are accessible and need to contact all metals being joined. 4. Fixturing. With brazing, you can invest as much effort as can fit into the furnace, so fixtures utilizing rods, hooks, or baskets are preferred. 5. Preheat. Heat up the parts to simply below the filter metal's melting point so that time in the furnace is diminished to a minimum, permitting more work to be dealt with. 6. Brazing. Eliminate from preheat and immerse in dip brazing furnace for 30 seconds to 3 minutes. 7. Quench. Frequently, parts should be air-cooled to a lower temperature prior to quenching to forestall distortion. 8. Cleaning. Flux should be taken out from the parts in the wake of quenching is completed by chemical or synthetic cleaning. What are things you should be aware of about the dip brazing process? A. Dip brazing isn't the only kind of brazing. Ancient metalsmiths, at last, refined the process into an early form of brazing to make valuable metal objects like cups. B. Dip brazing requires very controlled conditions. It's a benefit of the dip brazing process that it's most ideal for small, details assemblies. C. Brazing joins metals, but it's not welding of soldering.
Soldering is done at temperatures beneath 450 OC, 842 OF, though brazing requires a temperature somewhere in the range of 620 C and 870 C, 1150 F to 1600 F. D. Conditions needed for dip brazing. For dip brazing, you want a decent estimated, heat-resistant immersion tank for a bath in molten salt. Benefits of dip brazing. 1. Low tooling cost. 2. Less possibility of product distortion. 3. Higher quality at a lower cost. 4. Further developed strength. 5. Uniform and convenient. 6. Superior conductivity. Thanks for watching.